In the previous lecture, we talked about partial derivatives for functions of two independent variables, and also for more than two independent variables, we took partial differentiations. And now we also talked about the chain rule for two intermediate variables and two independent variables. We now have the functions with three intermediate variables and three independent variables. We talk about these type of functions to find the chain rule for those functions. Here, we say to let W to be the function of f of u, v, and r, where u, v, and r are functions of x, y, and z. Here we have W is a function of u, v, and r. W is a function of u, v, and r. U, v, and r. And each of these intermediate variables is a function of x, y, and z. That means u is a function of x, y, and z. X, y, z. V is also a function of x, y, and z. R is also x, y, and z. Each of these functions, I mean intermediate variables, is a function of x, y, and z. Now, if you want to find partial w by partial x, how to get that? Partial w by partial x. Here we have x, here we have x, and here we have x. To find partial w by partial x, but how to find it? We say it equals partial w by partial u times partial u by partial x plus partial w by partial v times partial v by partial x, then plus partial w by partial r times partial r by partial x. This is partial w by partial x. And for partial w by partial y, we do the same, but for y. Look, for y, we say partial w by partial u times partial u by partial y, then partial w by partial v, then v by y, w by r, and partial w by partial r times partial r by partial y. This is partial w by partial y. And then for z, we do the same. We say partial w by partial z, partial w by partial z equals partial w by partial u times partial u by partial z, partial w by partial v times partial v by partial z, partial w by partial r times partial r by partial z. That's all. That's all partial differentiations for the functions with the three intermediate variables and three independent variables. Okay, these are the partial derivatives by using chain rule. This process is called chain rule. Okay, here we should find partial w by partial x, partial w by partial y, partial w by partial z. If w to be a function of r, s, and t, w is a function of r, s, and t, and each of these functions, each of these variables is a function of x, y, and z. Then r is x squared plus y squared plus z squared. S is x, y, z. T is x, y, x, z, y, z. Here, these are functions of x, y, and z. And even here, we have only y and z, but we don't care about it. Okay, derivative of r of t with respect to x is 0 because we have no x in it. Okay, so now to find partial w by partial x, you should know these rules: this, and that one. To not forget the rules, it's easier to use this diagram, to use this tree. This tree is a really good way to not forget the rules. Okay? Do you know how to use this tree? This one? I mean, it's easy to write down all the chain rules. Okay, now for finding partial w by partial x, first we write down the rule. We say partial w by partial x equals. We have these three variables in w, r, s, and t. That means it's partial w by partial r times partial r by partial x plus partial w by partial s times partial s by partial x plus partial w by partial t times partial t by partial x. This is partial derivative with respect to x by using chain rule. Now we are going to find the partial derivatives. Okay, what's partial w by partial r? The derivative of w with respect to r, this term becomes 0 because here you have no r. This term becomes 0 also. How about this one? It's 2r. So partial w by partial r is 2r, is it? Then partial w by partial s is, what's partial w by partial s? Derivative of this function, yeah, it's 1. Because here, this term becomes 0, and this term also. And you just get derivative of s, which is 1. And partial w by partial t is 2, is it? Okay, and now we plug in the derivatives here in the rule. We say partial w by partial x equals partial w by partial r, which is 2r, times partial r by partial x. What's the derivative of r with respect to x? R with x. I mean the derivative of this function with respect to x. What's that? It's 2x plus partial w by partial s, which is 1, times, that's it, partial s by partial x. What's the derivative of this function with respect to x? It's yz, is it? It's yz plus partial w by partial t, which is 2, times partial t by partial x. Here you have no x, that means it's 0. So you say partial w by partial x equals 4rx, yeah, multiplication of these two, you get 4rs plus yz plus 0, and that's all. So this is partial w by partial x. But here in partial w by partial x, we have r. We have r. We must have no r, s, and t in it. We must only have x, y, and z, only the independent variables. So r is x squared plus y squared plus s squared. We just replaced by the function, and we get 4x times x squared plus y squared plus z squared. This is r. Then plus xy. This is so plus yz, not xy. This is the partial derivative of the function w with respect to x. And then was yes. ليه هو هاد؟ علين partial w by partial r. ده تساوي w بنسبة r تشيك هذا. ده شوي أمنح شوي بنسبة r. بله. بله. بله بله. ببي ار x تاني يا اخوي اي chain rule بتعرفين we should use chain rule because you have no x in it but we have x in the intermediate variable functions. We have x, y, and z in the intermediate variable functions. These are intermediate variables, r, s, and t. But x, y, and z are the independent variables. Here we have no x. To find the derivative of w, or partial derivative of w with respect to x, we use this rule. Okay? And with respect to y, and also z, let's find the partial derivative of the function with respect to y. Say partial w by partial y. It equals partial w by partial r times partial r by partial y plus partial w by partial s times partial s by partial y plus partial w by partial t times partial t by partial y. This is the rule. Okay? If we know the tree, it's easy to write down this. Okay? Let's find partial w by partial r, partial r by partial, partial w by partial s, partial s by partial, partial w by partial t, partial t by partial y. Okay? That means we are going to find partial w, I mean the partial derivative of w with respect to r, s, and t. We found it before. These are the partial derivative of w with respect to r, s, and t. Is 2r is a partial w by partial r is 2r. Partial w by partial s is 1. Partial w by partial t is 2. We found this. And now we should have partial r by partial y, partial s by partial y, partial t by partial y. We have to have these three partial derivatives also. That means we are going to find the partial derivative of r, s, and t with respect to y. So these are r, s, and t. These are r, s, and t. To find the partial derivatives of these three functions with respect to y, partial r by partial y is, I mean derivative of this function with respect to y. Derivative of this function with respect to y, these two terms become 0. So we get only 2y. We get only 2y. So partial r by partial y equals to r, 2y. How about partial s by partial y? The derivative of s with respect to y. It's x, z. You only get x and z. Okay? Because here you have x, y, z. It also equals to y times x, z. This is constant. Derivative of y is 1. So you get only the constant which is x, z. Is it? S equals x, y, z. Finding partial derivative of this function with respect to y, we get xz. Means partial s by partial y equals xz. And then partial t by partial y. That equals what? It's z squared, is it? Yeah. Derivative of this function with respect to y, it's only z squared. Look, this becomes 1 and it's a constant. We just write down the same. So you get y squared. So z squared. Partial t by partial y equals z squared. Let's replace these into the formula above. So partial w by partial y equals. It equals partial w by partial r. What's partial w by partial r? We found this. It's 2r. Times partial r by partial y. It's 2y. Plus partial w by partial s. It's 1. times partial s by partial y xz plus partial w by partial t, which is 2. Partial t by partial y, 2 times z squared, not comma. That's all. And now if you have r, s, and t, replace them by their functions, okay, to get only x, y, and z in the solution. We say partial w by partial y equals 2 times 2 is 4 y r, is it? Plus here 1 times xz is still xz plus 2 z squared. But here we have r. We must have no r, s, and t. I mean intermediate variables. So what's r? R is given that it equals x squared plus y squared plus z squared. Is it? So you just replace r by x squared plus y squared plus z squared. And we get partial w by partial y equals 4y x squared plus y squared plus z squared plus xz plus 2z squared. This is partial w by partial y. How about z? We do the same. We are going to find partial w by partial r, partial w by partial s, and by t. Then also we are going to find the partial derivative of r, s, and t with respect to z. And then write down the solution. Okay. So the most important thing here is to know how to write down these rules. Do not memorize them. Okay. If you understand from this tree, that's all you need. Okay. I'm gonna talk about the tree again. Okay. Here we say to find in the function w, we have u, v, and r. Okay, these are intermediate variables, and u is a function of x, y, z. V is a function of x, y, z. R is a function of x, y, z. Okay, that is w. In w, we have 3 intermediate variables, which are u, v, r. R, U, V. Okay? It's okay if you write down in any order. It's okay, no problem. That's it. Then R is a function of x, y, and z. X, y, and z. U is a function of x, y, and z. X, y, and z. V is a function of x, y, and z. Now, if you want to find partial w by partial x, let's say by partial x. Look, this is w. This is x, and this is x, and this is x also. We say partial w by partial x equals partial, look, that's it. Partial w by partial x equals partial w by partial r times partial r by partial x. Partial w by partial r time, sorry.
Partial w by partial u.
It's okay. It's not, even if it's not in the same order, it's okay. No problem. Okay. Because you have this plus that. We can change the places. It's okay. No problem. Let's write down in the same order. It's better for you to not confuse. Okay. U, V, and R. Okay. Look, partial w by partial x equals partial w by partial u times partial u by partial x. Look, partial w by partial u times partial u by partial x. Then plus partial w by partial v times partial v by partial x. That's it. Then plus partial w by partial r times partial r by partial x. That's the rule. For y and z, it's the same. Okay, it's the same for y and z. So what if you have only x and y here? So what if you have only x and y in G, in U, V, and R? Here, we just delete this one. That means here we can just find partial derivative of w with respect to x and y. We cannot find it with respect to z because here we have no z. We have no z here. In this case, we have only two independent variables. And we just can find partial derivative of w with respect to x and with respect to y. But if you have z, we can find with respect to z also. And for y,
partial u over x, partial u over y.
look, partial w by partial. No.
Partial u over x multiply partial u over y.
For which case? For finding partial w by partial x or partial w by partial y. ليرة أتيجي بدو شو داوا كراو. أجر أما داوا كراو تنها بالنسبة لإكس داوا بيدوس. It could be w or sub xy. I mean partial w by partial x first, and then finding with respect to y. Okay. Which here ليه كاتارد كناكي دو جار داتا شاو داتا شاو يكون دوستو دوات داتا شاو ليه كاتانية بهر بكن داتا شاو بالنسبة لي ناشتيواني okay هر جارة بالنسبة لي so is that easy? Please try to know this tree and you don't need to memorize the rules. Okay, if you just know this tree, you don't need to memorize the rules. Sorry? Yes, of course. Okay. And if you have three intermediate variables and only one independent variable, if you have only one independent variable, that means it's not partial derivative, it's only differentiation. And we don't denote it by partial, we denote by d. Okay? In here, if you have f of x, when we find the derivative of this function, we say df by dx, is it? So what about f of xy? If you have more than one independent variable, we say partial f by partial x. Is it? Or partial f by partial y. Here, for functions of more than one independent variable, we use partial derivative. But if you have only one variable and one independent variable in the function, we use df by d variable, d of the independent variable. Here we have an example like that. We don't need to use partial, we just need to use d. If the independent variable, here we have only one independent variable. As you see here, we should find dw by dt. For which function? For the function w to be xyz. In w, we have no t, and we should find the derivative of the function with respect to t. But we have given functions x, y, and z. Okay, we have given functions x, y, and z. It says each of them is a function of t. X is t cubed, y is t squared, z is t to the power 4. As you see, we have only one independent variable. The independent variable is this one. In the previous example, the independent variables are x, y, and z, not u, v, and w, u, v, and r. Okay, rs, sorry, here rs and t, I mean. Yeah, these are not independent variables. These are called intermediate variables. These are the independent variables. I mean, X, Y, and Z are the independent variables, not RS and T. And here we have given a function of W, which is a function of X, Y, and Z. And we should find the derivative of W with respect to T. But in the function of W, we have no T. We have only the intermediate variables, which are X, Y, and Z. Each of these intermediate variables is a function of T. That means we have only one independent variable. That means here we have only one independent variable. When you find the derivative of X with respect to T, we say dx by dt. We don't say partial X by partial T. But here, when you find the derivative of W with respect to X, we say partial W by partial X. Partial W by partial Y. Partial W by partial Z. ليرة أجر نقشك يك variable يتيابو عن D. أجر زيادة له variable يتيابو عن partial. Okay. Here for W, when we take derivative of W with respect to variables, we say partial W by partial each variable. Then for X, we say dx by dt. How about Y? We say dy by dt. How about Z? We say dz by dt. Let's find them. Okay. And then finding the derivative of the function W with respect to T. ليرة data شاوي W بالنسبة ل T بالنسبة هيك كاملة variable عنية بودي ما دانا ولا بالنسبة أو variable عنه بيت the partial داني. Okay. بالنسبة ل T بلان چند تيم هي چند variable چند independent variable هي. Okay. So you say let's write down the rule. To find it, here we say, this is W. In W, we have X, Y, and Z. In X, we have T. In Y, we have T. In Z, we have only T. So partial W by partial T is partial W by partial X times partial X by partial T. Say partial W by partial T equals partial W by partial T, sorry, by partial X times partial X by partial T. So dx by dt. And even this one is D. As you see, for only derivative of W with respect to X, Y, and Z, we write down partial. For others, we just write D plus partial W by partial Y times dy by dt plus partial W by partial Z times dz by dt. Let's find these partial derivatives. We have six derivatives actually. Let's find the derivative of W, partial derivative of W with respect to X, Y, and Z. Partial W by partial X, sorry. What's partial W by partial X? This YZ, is it? It's YZ. How about partial W by partial Y? It's XZ. How about partial W by partial X? Okay. And so how about partial X by, sorry, dx by dt? dy by dt. dz by dt. Finding the derivative of X, Y, and Z with respect to T. 3t squared, 2t, 4t cubed. Now we replace this into the formula. So dw by dt equals partial w by partial x, which is yz. That's yz. Times dx by dt is 3t squared, then plus partial w by partial y, which is xz, times dy by dt, which is 2t, plus partial w by partial z, which is xy, times 4t cubed. Now we are going to replace each x, y, and z by their functions, of t. Okay, we say x is t cubed, y is t squared, and z is t to the power 4. Example. Z is t to the power 4. We replace. You see, x is t cubed, y is t squared, and z is t to the power 4. We replace each x by t cubed, each y by t squared, and each z by t to the power 4. That means dw by dt equals yz, what's t to the power 6, t to the power 8, 3, t to the power 8. The result of the first term is 3 t to the power. Look, here we have y times z, t squared times t to the power 4, t to the power 6. And here we have t squared also. It becomes t to the power 8. We have 3. We have t squared times t to the power 4 times 3t squared. That equals 3t to the power 8. Is it? Just add the exponents. لأن نابي x y تيابت لأن solution كه بو لبري x y تشين independent variable مين intermediate variable x y z تشين تيابت اللي شو independent variable كمان تشيا تنهاتية أنجام بابس تيابت أوكي نابي أواني ناوراس أو ناوراس تريكي تيابت ناوراس تريكي شو معناه x y z نابي السولوشن تاعها بلام انا دراون فانكشنال اكس تي جايه واي تي جايه زد تي 20 شوارع دراون تنها داني نوتاوس. For the second theorem, x is t cubed times z is t to the power 4 with t to the power 7 times 2t. We get 2t to the power 8. Is it? This is t to the power 7. And here we have t, it becomes t to the power 8. Then here we have x is t to t cubed, 5, 8. So this. So the result is 9, 8, 9t to the power 8. This is the result. So that's the partial derivative. I mean, dw by dt. Not partial derivative. That's dw by dt. As you see in the previous example, also we replaced r by its function because r is an intermediate variable. It's not an independent variable. Okay. We now have implicit function. For finding the derivative of implicit function, if we have an implicit function, we say this is chain rule. This is chain rule. If we have two intermediate variables and one independent variable, okay, that's the chain rule for it. Here we say dy by dx. If we have f of xy, if we have a function of f of xy, and if you want to find dy by dx, if you want to find dy by dx, I mean the function is implicit. Here the function is implicit. In the example, it will be much clearer. We say it equals capital F sub x divided by capital F sub y, and then we have a negative sign here. This is dy by dx. I'm going to tell you what's capital F. Okay. Here it's a theorem. We say if we have capital F of xy equals 0, then dy by dx. Here we have no y function. We have y in the function of capital F. We have y in the function of capital F. To find dy by dx, we say it equals minus capital F sub x divided by capital F sub y for the function. Let's take an example. If you have x squared y squared plus 2x squared of y plus y cubed plus x cubed equals 0. Here, this side I mean, one of the side must be 0. Okay. If there is any theorem here, we move it to the left hand side. Then we say the left hand side is capital F of xy. ليه ده تساوي شلون خو بخويا خو بخوي بيلا implicit. Okay. ليه عقب ما dy by dx equals checking. We say we are going to find the derivative of this function with respect to x. Then dividing by the derivative of the function with respect to y. Then we give a negative sign to the result. That's all. As you see here, we have this rule. We just use this rule for finding implicit differentiation with respect to y. Here we have an example. Here we say if capital F of xy must be 0, that means the right hand side must be 0 in the function. We have given this function, and we should find dy by dx. We should find dy by dx. Here we use implicit differentiation. We use implicit differentiation. How? We are going to make the right hand side 0 by moving all terms in the right to left, and you get y to the power 4 plus 3y minus 4x cubed minus 5x minus 1 equals 0. This part, I mean the left hand side, is f of capital F of x and y, which equals 0. Applying the above theorem, we say if we have a function like this and we want to find dy by dx, we have just used this rule. We just use this rule. That means we are going to find derivative of capital F with respect to x, and also derivative of capital F with respect to y. And then we divide f sub x by f sub y, and we give a negative sign. That's all. This negative sign to f sub x dividing f sub y. Let's find. So if capital F, we say capital F of xy equals y to the power 4 plus 3y minus 4x cubed minus 5x minus 1. This is a capital F of xy. What we do, we are going to find only these two partial derivatives. That's all. تنها أمر لا تشاهد سينوطا f sub x f sub y. ده بشأن كده ناقص كم ده. هاد only إيش تنمي. So here we say capital F sub x of xy equals to what? The partial derivative of this function with respect to x. The first term becomes 0 because in this term we have no x, we have only y. And the second term also becomes 0 because even in this term we have no x, we just have y. And the third term becomes minus 12x squared, is it? If we find the derivative for this term with respect to x, what we get? It's minus 12x squared. How about minus 5x? The derivative of this function with respect to x is minus 5. How about minus 1? As the derivative is 0 because it's a constant. Now this is f sub x. To find f sub y, derivative of y to the power 4 is 4y cubed. Then plus 3. Other terms become 0 because we have no y in the other terms. These are f sub x and f sub y. So dy by dx equals minus f sub x dividing by f sub y. Okay. It equals, what's f sub x? First, let's put the negative sign here. F sub x is minus 12 minus 12x squared minus 5. And f sub y is 4y cubed plus 3. And if we insert this negative sign to the numerator, we get dy by dx equals 12x squared plus 5 dividing by 4y cubed plus 3. That's all. It's for the rule. Yep. Yes. It's in this calculation. I get it. Yeah. You don't need to know the proof. Okay. Only know the rule. Minus f sub x over f sub y. That's all. That's for implicit differentiation. So if you have more than two variables, let's say if you have capital F of x, y, z equals 0, that's implicitly defined as a differentiable function z as a function of two variables x and y. We say partial z by partial x equals. It's the same rule. It's the same rule. But here we have three variables. I find partial z by partial x. It equals minus f sub x over f sub z. And partial z by partial y equals minus f sub y over f sub z. In both with respect to x, I mean z with respect to x, and then z with respect to y. In both, we just say f sub x over f sub z and f sub y over f sub z. And here we have this negative sign also. We have the same rule. It's the same rule. So let's find the partial derivative for this function. Okay, I haven't left. Here we have given this function. We have given this function. To find partial derivative of this function with respect to x, I mean partial z by partial x and partial z by partial y. First, let's find partial z by partial x. Before we do that, we must find capital F of x, y, z. We move this to the left first. We move sine z to the left. Okay, we move this to the left because we say capital F of xy must be equal to 0. That means if there is any term in the right hand side, you will move it to the left. And so we say f of x, y, z equals xy squared plus zy plus x sine z. Is that equals 0? We just move to the left and say capital F of x, y, z. Now we are going to find capital F sub x, capital F sub y, and capital F sub z. To find, as you see here, to find partial z by partial x, we need partial f sub x and f sub z. And for this one, we need f sub y and f sub z. That means here we just need f sub x, f sub y, and f sub z to get those partial derivatives. Here, f sub x equals what? What's f sub x? It's y squared plus sine z. Y squared plus sine z. How about f sub y? The last term is 0. The first term is 2xy. Is it? It's 2xy plus z. And how about f sub z? First term is 0. Second term is y plus x cosine z. Is it? Derivative of sine z is cosine z. These are the partial derivatives. So how about f sub x? You say, so no, not f sub x, partial x, partial z by partial x. We say partial z by partial x equals f sub x minus capital F sub x dividing by capital F subset and equals to, what's f sub x? Capital F sub x is y squared plus sine z, and f sub z is y plus x cosine z. That's all. This is partial z by partial x. How about partial z by partial y? We say partial z by partial y equals minus f sub y over f sub z. F sub y is 2xy plus z. So you have a negative sign minus 2xy plus z dividing by y plus x cosine z. That's all. Is that difficult? If you only leave me assignment, it's not difficult. It's easy. The assignment is also not difficult. So easy. الموضوع عنها الأول هيك كده يعني. Okay. So let's take a break. Here we say in this section to this chapter we have local extrema. So extrema refers to either maximum or minimum. Here you have a definition. It says suppose z to be a function of f of xy. It's a function of two variables defined in the domain D. The function is defined in this domain, where AB is in the domain. AB is a point in the domain. Okay. Before we talk about this, before we talk about maximum and minimum in functions of two variables, let's review the maximum and minimum for the function of one variable. I'm going to write down it here. We say if you have a function, let's say f of xy, f of x, this for a single variable function, y to be f of x and to be, let's say, x squared plus 2, x squared plus 2. To find the maximum and minimum or minimum for this function, what we do, we say we first find its derivative. But here we have only one variable. So you say f sub x. We are going to find f sub x. It's 2x. We equal this to 0. Then we find the value of x. Okay. Here we are going to find critical point. Okay. Here from this x is 0. If x is 0, we are going to return this to the function. So f of 0 is 2, is it? So the point is 0 and 2. This is the point. I mean, x is 0 here. Let's see, add x to be 0. The function is at maximum or minimum. How do we do that? We are going to find the increasing and decreasing area. Now, we say, let's say this line to be f prime, and here we have 0. We pick a point somewhere here, and also pick a point somewhere here, and return them to the derivative. F is bigger than 0 means it's increasing. The function is increasing in that interval. And if is negative means the function is decreasing in that interval. Let's pick a point here. Pick any point bigger than 0. let's say 1. If you, so f of 1 is 2, which is greater than 0. That means here, in this part, in this interval, the function is increasing. And let's pick a point here. Let's say -1. F prime of -1 is, look, this f prime. F prime -1. And let's say f prime, it's better. F prime of -1, this is x. We just replace x by -1 and we get -2. And here we get negative values. That means if we pick any point in this interval, we get a negative value for less than 0. And for bigger than 0, if we pick any point, the function is, the derivative of the function is positive. That means here is decreasing, And here in this interval is increasing. So at 0, the function is at minimum. It's at minimum. Because if we just follow these arrows, as you see, this is minimum. That means at 0, at x to be 0, f is at minimum. F is at minimum. And the minimum point is 0 and 2. This is the minimum point. So the critical point is a minimum point. Here, we see the critical points are either minimum or maximum. Okay, as in first, in one variable, in one independent variable functions. But for two independent variables, we say it's either maximum, minimum, or saddle points. It's either minimum, maximum, or saddle points. So that's for functions of first of one variable. We say what we do, we are going to find the derivative of the function. We equal this to 0, and then to find the critical point. And so we are going to find the maximum or minimum of the critical point. If the critical point is either maximum or minimum, it's not both at the same time. And here for functions of two variables, what we say, if we have D to be the domain, if D to be the domain, and the function is defined at the domain, we say, if we pick a point, we say AB in the domain. We say if AB to be in the domain. Say f of AB is called local maximum. It's called local maximum. F of AB is called local maximum. If the function, if there exists the region R to be in D, such that AB is in R and f of AB is greater than all the other images of the points in the region. Yeah, let's see if we have, let's say this is D, this is D, this is the domain. And in the domain, if we pick an interval, if in this interval we have AB, if at AB the function is at maximum here, we say the function is at maximum at AB. If f of AB is greater than all of its neighbors. Okay, sorry. Yes, that means at AB the function is at maximum if f of AB is greater than all of its neighbors. Okay, for example here, if we have this graph, let's say this graph, in this, if this is the domain, in this domain, in this region, this point is minimum, and in this region this point is maximum. But this maximum and this minimum in functions of two variables is called local minimum and local maximum. Don't say only maximum or minimum, say local maximum or local minimum. But if at a point the function is at maximum at all, for example, if you have only this, if you have only this graph, if this is the I'm going to down from both sides. So at this point, it's called absolute maximum because it's bigger than all of the points in the domain. Okay, اگر هاتو او بوينتي كهمانه جولتر بقول لا لدوري بركي خوي او بيوتو لوكال بلا اگر هاتو جولتر بقول همو دومينك بيوتو absolute maximum بلا بوب سوتريش بهماشي. Okay, but here we first talk about the local maximum and local minimum. That's for local maximum. And for minimum, it's the same. If f of AB is greater than all of its neighbors, means at AB the function is at local. If it's less than all of its neighbors, we say at AB the function is at minimum. Okay. We say suppose f of AB is a local maximum or local minimum of the function f of xy. If f sub x and f sub y exist at the point AB, then the derivatives must be equal at that point. The derivatives must be equal at that point. F sub x must be equal at AB, and f sub y at AB must be equal to 0. Look, yeah, in both must equal to 0. ليه خالي شلوقه لخالي شلوقه داتا شاوت شيء صفر يعني داتا شاوت ثاني كم صفر لخالي شلوقه كواتلي داتا شاوت هر دو كيف بمشي بصفر شو خالق أبيته maximum minimum. What are the points which become maximum and minimum or minimum? Only the critical points. I mean خالي شلوقه كان تنها خالي شلوقه كان أبدا maximum minimum. Okay, local maximum and local. So at the local maximum, if at AB, a function is at maximum or at local minimum, we say the partial derivatives with respect to x at the point, and also the partial derivative with respect to y at the point must be 0. Both partial derivatives must be 0. Here, you say the reverse is not true because you say if f sub x and f sub y equals 0 at a point, it doesn't mean that at that point we have a critical point. Okay? But if at a point we have local maximum or minimum, means at the point is a critical point. The point is a critical point, and at this point must be first derivatives of x and y with respect to x and with respect to y to be 0. But here, for finding the local maximum and local minimum, we use second derivative test. We use second derivative test. That's much easier. Okay. We say a pair AB such that f sub x to be 0 and f sub y to be 0 is called critical point or stationary point. If at a point both partial derivatives is 0, then we say the point is called critical point or stationary point. So this point, if at this point f sub x to be 0 and f sub y to be 0, if both are 0, then we say this point is called critical point or stationary point. Critical معناه خالي شلون. It's okay. Here we say to find or to determine a point is local maximum or local minimum or a saddle point, we use this Jacobian for the function at a point. We first should find the critical point. how we find f sub x and f sub y. We equal both to 0. Then you find the values of x and y. After finding the values of x and y, those values of x and y become the critical points. At the critical points, we are going to find this Jacobian as the determinants of f sub xx at AB. Let's say AB is the critical point. So f sub xx at AB, f sub xy at AB, f sub yx at AB, and f sub yy at AB. We are going to find these for second partial derivatives. And then we find the determinant of this matrix. As a determinant matrix, we say determinant of A, B, C, and D. It equals AD minus CB. AD minus CB. This is the determinant. And here, to find the determinant, we say we multiply these two, then minus, we multiply these two. But be careful. These two, both partial derivatives with the same variable, f sub xx and f sub y. We multiply these two. Minus f sub yx times f sub xy. And here it says the function is continuous. And we said that if a function is continuous, f sub xy equals to f sub yx. F sub xy equals f sub yx. These two are equal. This equals to that one. If the function is continuous. So we say if these two are equal, we can say it equals to f sub xy squared or f sub yx squared in the multiplication of these two. We say f sub xy equals f sub xy equals f sub yx. That means f sub xy times f sub yx. We can say it equals f sub xy squared or f sub yx squared. You can take only one of them and then square it. To find g, we are going to find g. G is f sub xx times f sub yy at the point minus f sub xy squared at the point. This is g of AB. And then we decide from the values of g, if it's positive, if it's negative, or if it's 0. To determine the point is maximum or minimum. We say if g is bigger than 0 and f sub xx is less than 0, then the point is maximum. Then the point is maximum point. If g is greater than 0 and f sub xx is also greater than 0, if both are greater than 0, we say it's minimum. It's local minimum. If g is less than 0, look in the both cases above for maximum and minimum, g must be greater than 0. And f sub xx, if it's less than 0, we say it's maximum. If it's greater than 0, we say it's minimum. But if g is less than 0, we have no condition on f sub xx. If it's only less than 0, we say it's a saddle point. That's a saddle point. But if it's 0, we say we have no conclusion. And so it's neither maximum, no minimum, no saddle points. That's none of them. Okay? So you have only these 4 cases for G and for finding local maximum, local minimum, and saddle points. For maximum and minimum, G must be greater than 0. And if f sub xx is greater than 0, we say that's minimum. If f sub xx is less than 0, we say that's maximum. But if g is less than 0, we say that's saddle point. And if g is 0, say that's none of them. Here you have an example. I'm just going to do the first one. Oh, I have no time. So it's enough for today. For tomorrow, I'm gonna just give a quick review for what we talked about here in this section. Then we try to solve the examples, and then we finish up this chapter.